Okay, so in this video, y'all, again, just depending on your organic premise, on your, excuse me, just depending on your organic chemistry professor and what kind of mood he's in that day when he's writing your exam, you might see this on a free response exam. You might not. Hey, I mean, this might be a homework question for some of y'all. But again, just depends on the difficulty of your organic chemistry course. But for somebody like me, I saw these types of questions when I was in undergraduate chemistry. So I just really quickly want to go over this reaction mechanism here. It's kind of a fun, it's a really fun one, honestly. So I hope you all get some joy from doing this from doing this problem here. So I'm just going to take you all through this mechanism. Again, on an exam, they're not going to ask you to predict these products here. You're not going to get asked to predict that product there. They're going to give you the product, and they're going to ask you for the step-by-step mechanism, or in other words, the stepwise mechanism, showing arrows and pushing electrons. So that's exactly what we're going to do here. So let's go ahead and get started. And the first thing we're going to do, so I am just going to eliminate here the sodium ion. Again, the sodium ion is part of the net ionic, it's not part of the net ionic reaction. It's just the spectator ion there. So sodium really doesn't play any part in this, doesn't do anything in this reaction. So I'm just going to eliminate it. Again, it's a spectator ion. So what we're really working with is this hydroxyl ion here. So this hydroxide is the one that's doing all the action. The first thing that happens here is you're going to deprotonate. Now, I know in my previous videos I've been talking about protonating. Well, that is because you had an acid and a base. You had an acid. So those were for acid catalyzed reactions. This is not an acid catalyzed reaction anymore. It's a base catalyzed reaction. So our first step is not protonation. Our first step is deprotonation. And so what are we going to deprotonate? And that's going to be our acidic hydrogen here. So that's what gets deprotonated. So our first step is deprotonation. So that hydroxyl ion goes after that proton right there. And then by default, these electrons are going to jump on oxygen right here. And so the first thing we make here is going to be something that looks like this. Just bear with me here. I'm going to draw this out really quickly. So the first thing we make here is something that goes like this. And of course you make plus H2O on this side when you combine these two, HO and H right here. So you make H2O. And so this is the first step in our mechanism, making that oxide ion right there. And so what happens now is you're going to get something kind of like it's going to be nucleophilic attack. So this is going to be your nucleophile here, this oxide here, because that has the electrons, and it's going to attack so it's going to look for an electron deficient carbon. And so where's our electron deficient carbon here? And in this case, that electron deficient carbon happens to be right there. That's the electron deficient carbon. That's where the oxide is going to attack. The reason for that is because you can draw a resonance structure that shows that carbonyl carbon there. So this is your carbonyl carbon. So that carbonyl carbon is electron deficient. You can push these electrons onto oxygen and show that you can make a carbocation on that carbon. And so that's why this oxide anion attacks that carbon, because this is the carbon that is electron deficient. So it's going to be really, really similar, really analogous to like an SN1 mechanism, although it's not an SN1 mechanism, but it's a little bit analogous to that. All right, so what happens is these electrons get pushed on oxygen now, and we're going to form our next product here. So, and again, this is really awesome, y'all. So this is going to look a little funky, but just stay with me here. And you guys are I hope you guys appreciate this type of problem. It's really, really cool. So you're gonna get something, excuse me, you're gonna get something along the lines like this. Oh, sorry, and I should have drawn. There's an oh no, sorry. Let me go back. There's an oxygen here, and there should be an oxygen right here. So sorry about that. There you go. There's an oxygen right there. So I just totally forgot to draw it out. But yes, so this is our electron deficient carbon, and so that bond here, so now we have a bond between this oxygen here and that carbon right there. So that's going to be our bond. I know it looks a little crazy, but just trust me. We're going somewhere with this. We are. So just there's a bond there. There's a bond between that oxygen and that carbon. So I'm going to go ahead and go to the next slide, and I'm just going to redraw that just to make things just a tad bit clearer. So just to show things in a much clearer way. So that's what I'm going to do here. So, oh, sorry, we have the iodide here. And again, we have this oxygen, and we have that. And we have this oxide, and that is forming a bond like that. Just like that. So I know that looks a little funky, but just stay with me. So what's going to happen is, now this oxygen, it's negatively charged, has 6 electrons on it. If you calculate its formal charge, you'll know that it has 6 electrons. You should know that by now. So what happens is, these electrons are going to come back down and close on that carbon-oxygen bond to form a carbonyl again. And when that happens, this is going to act, this moiety right here, I'm going to undo this, but this here is going to be your leaving group. So that is going to be your leaving group now. And the bond you created between the bond you created here, the bond you created here, it's no longer negatively charged. I'm sorry about that. That's no longer negatively charged because you created a bond. The bond you created there is going to stay there. And so this is going to be your leaving group now. So that is going to leave. So that oxygen is going to leave now. So again, these electrons are going to come back down between that carbon and the oxygen to reform their carbonyl, and then these electrons are going to jump on oxygen, and this is going to serve as your leaving group. And so what the product from that is going to look like, it's going to look something like this. One. Like that. And so now this oxide here is free. It's free from that bond right there that we initially had. So now we have something like this. Excuse me. So now we have that. All right, and I'm going to erase this here, and I'm going to just, there you go. I'm going to redraw that arrow. So now we have that. Okay, so we're essentially almost there. We're almost home. We're almost there at the end of this. And so, that's basically, we're almost towards the end. But the important part of this reaction here is getting here. This is the important part. And the tricky part of this mechanism is this part right here. So knowing that the electrons from this oxygen here come back down, close on that carbonyl carbon. You reform that carbonyl group, and then these electrons here jump on oxygen, which this entire group here will be your leaving group, forming that oxygen right there. That it's an anion now, so that's an oxide. Okay, so and we formed this group right here, which was what we needed to form in order for us to be able to solve this mechanism. So now let me go to the next page. Let me go to the next let me go to the next slide and show you all how we get to our final product. So our final product now, again, I'm going to redraw this. So we have this. We have that. And we have this oxide here. And we have this iodine here. So what's going to happen here now is we're going to form the epoxide. And again, like you all learned, this is going to be kind of like an SN2 reaction. So it's perfect because we can do backside attack here. So what's going to happen here? It's perfect that our leaving group is on the wedge, because actually, if it wasn't on the wedge, then you know, this wouldn't really be possible. But because it is on the wedge, so this oxide here, excuse me, I'm going to do it in a different color. This oxide is simply going to do backside attack here. And let me redraw the arrow. So right there, it's basically just an epoxide. You're just basically forming an epoxide there, kind of like an SN2 fashion, honestly. So, and that's what happens. You form an epoxide. That's a great leaving group right there. So that leaving group is going to leave, and that's essentially the end of the problem. So, in closure, you're going to get this. All right, so you get that, and yeah, and you get that, and there's your final product, plus, so that's a plus, I minus, because obviously I minus went into solution, and you know, that later will combine with that's later going to combine with the sodium that was floating around, so you're going to form NaI, and remember we initially formed water, so we have plus water. I mean, that's just, you know, for completeness sake, but again, you know, this isn't, these guys here are just spectator ions. They're not really part of, they're not really part of the final the final product that you care about. So this is what we care about here. So, but just, you know, just to be thorough, and that's how you get your final product. So that is the mechanism for this problem. So let's go ahead and go back and check it out. And yes, we were correct. So that's what we needed. That's what we needed, and that is what we got. So, all right, good job, y'all. So, you know, these are just a few fun mechanisms you can do, or you can try. Again, it just depends on your class and your professor, on the difficulty, but this is something that could potentially pop up on an exam. So I just really wanted to go over it step by step and explain each step of the way with you all. So I really hope these videos have helped. I'm sorry, sometimes, you know, it's hard to go through these from 0 seconds to the end of the video without making any mistakes. So I'm really sorry about that, but you know, I corrected myself along the way, and hopefully this goes a long way to helping somebody in this course. So thank you very much for watching. Stay tuned for other videos. I'm going to be uploading other videos very soon, so please go ahead and subscribe to my channel if you haven't already, and leave a comment down below if this helped you or not. So thank you very, very much for watching.